The atmosphere isn't a solid lid, it's more like a partially transparent blanket. Energy still escapes to space, but not quite as quickly. The debate is mostly about how much that slowdown matters and what effects it has over decades and centuries. That's a couple different questions. You're connecting a lot of ideas here: climate, stars, matter, energy, information, and the forces that hold these things together. Some of your intuitions are surprisingly close to questions physicists have asked for centuries. A few thoughts about the apocalypse scenario. What climate scientists worry about is generally not the Earth turning into the sun or everyone suddenly burning to a crisp. The concern is more that sea levels rise, weather patterns shift, some regions become hotter, drier, or harder to live in. Okay, wait, what's the concern? Sea levels rise, weather patterns shift, some regions become hotter, drier, or harder to live in. Coastal flooding becomes more common, ecosystems struggle to adapt. It will be more like a gradual disruption than a Hollywood doomsday movie. That said, if Earth somehow trapped all outgoing heat, temperatures would keep rising, but that's not what current climate models predict. Is Earth's core a star? This is where your intuition and the science start to diverge. Earth's core is incredibly hot, but it is not a star. A star is powered by nuclear fission. The sun is continuously turning hydrogen into helium and releasing enormous amounts of energy. Earth's core is hot because it formed from massive collisions during the early solar system. It contains radioactive elements that release heat. The planet is under immense pressure. So Earth is more like a giant hot rock than a miniature sun. Okay. But there is a poetic truth behind something you said. The atoms in your body were forged into ancient stars. The atoms in your body were forged into ancient stars. In that sense, we are literally made of stardust. Could we make gasoline from CO2 and water? Yes. In principle, CO2 plus H2O plus energy is fuel. The challenge is providing enough energy and controlling that chemistry. Scientists are actively working on this. Is it arrangement of frequency? This is a really interesting question. In chemistry, the primary answer is arrangement. Imagine you have the same Lego pieces. You can build a house, a car, a tower. Some pieces, different arrangement. Chemists care enormously about which atoms are connected to which atoms. Okay. But you're also touching on something real when you talk about vibration. Atoms and molecules do vibrate. Different molecules vibrate at different frequencies. That's what I was saying. Frequencies. That's actually why CO2 absorbs infrared radiation and oxygen doesn't. To confirm, is it bad for CO2 to absorb infrared radiation, or is that what's supposed to be happening? Or is the infrared radiation supposed to be what? I don't know. Tell me. So frequency matters, but frequency alone doesn't determine what molecule you have. The arrangements matter too. Of course, duh. Of course that frequency alone doesn't determine what molecule you have. The arrangement matters, obviously, because it's like, that's saying that the arrangement doesn't matter is saying that you can take a bunch of words, throw them together randomly, and now you have a book. No, it's not just about knowing letters. It's not about just knowing words, but it's about knowing the relation to each other and the words that you can make from the letters. Then you use the words to form sentences. That's what makes books. The same way you can play a bunch of different notes on an instrument, but that doesn't mean that it's gonna sound good. It's about the arrangement and the order that you play the individual notes that matter. So obviously it all matters. But I'm saying we can make gas if we figure out what are the necessary elements, which are all naturally available, figure out what the natural elements are, and then we can do trial and error to figure out, or maybe, I don't know what the process is, you figure out how to connect them together. and then you provide the proper conditions for that, and then maybe it'll turn in the proper arrangements and in the certain conditions, like maybe a cool dark place, maybe it will turn back into gas. What is actually holding matter together? Not nothing. There are real forces. For example, electromagnetism holds atoms together. Chemical bonds hold molecules together. The strong nuclear force holds atomic nuclei together. Gravity holds planets and stars together. When you touch a table, what feels solid is mostly electromagnetic forces pushing back. The table and your hand are mostly empty space at the atomic level. Yet the forces are real. You're right that there is an unseen aspect to matter. Yes, physics doesn't describe matter as tiny billiard balls touching each other. It's fields and forces interacting. Was the oil heated by Earth's core? Not directly. Oil is found usually in the crust, relatively close to the surface compared with the size of the Earth. A simplified version, ancient plants and microorganisms died. They were buried under sediment. Heat and pressure transformed them over millions of years. Wait. Oh my gosh. Wait, were you saying that oil was created because of dead bugs? Wait, hold up. Okay. What? Where am I? Meow. Okay. Are you saying that plants and animals were heated to form oil? Too little heat and the transformation doesn't happen. Too much heat and the oil can break down further. So there is actually a kind of Goldilocks zone of temperature. Yes, that's what I'm saying, suggesting that we find out the proper temperature. What is the temperature of the crust of, like, can we not figure, we have to figure out if we're trying to get back to those same conditions, if the oil was stored in the Earth's crust, we could assume that is a good storage temperature. So whatever the temperature of the Earth's crust at the time of the oil pulling or something, I don't know if the temperature would have changed, but whatever, something along those lines, then we just recreate that same thing, right? So that, and it might be a process where it's like you said, it probably took time, right? It was like heated, and then you said, yes, heated and pressured over a period of time, but it doesn't heat build, or would it have been the same temperature the whole time? I don't know. Why can't we just store gas underground and turn it back into oil? Because burning oil changes the molecules. That is a key distinction. If I melt an ice cube, I still have H2O, but when gasoline burns, I no longer have gasoline. The atoms are still there, but they've been rearranged into different molecules. To get gasoline back, you must actively reconstruct those molecules. That's the hard part. Is it hard? I don't know. Well, if we have gasoline, don't we know what the proper structure is? Or can we not figure out what the proper structure of the molecules are and then just copy that by getting the same resources back? I don't know. That's the hard part. Light is carrying information. What information? This is one of my favorite questions. When you look at the sun, the light is carrying information about the sun's temperature, its composition, its motion, its age, its magnetic activity. Astronomers learn astonishing amounts from lights. The color, brightness, polarization, and spectrum all contain information. In a sense, light is the universe's messenger service. I was literally thinking, I'm saying, what if that's like the global communication center for the whole universe, and everybody could just send messages? And what if they're sending us messages now? Like, we're communicating with each other through the sun. Energy.